This is lesson 2.1 out of the Introduction to Algebra book. Lesson 2.1 has the title Variables and Expressions. So here's where we get our first introduction into what most students think of as true algebra, when we start using those letters mixed with the numbers, and you wonder, what is that all about? And we'll start getting a peek at that today. Warm-ups. First one is, what are two words that mean add? Okay, what are two words that mean add? And our second one, what is another word for subtraction? What is another word for subtraction? And the last one, find the value of 80 divided by 10 minus 2 times 4. Remember your order of operations on that one. All right. Okay, we have an I can statement. I'll skip a couple of lines so you got room for your PEMDAS triangle there. We have an I can statement today of I can write expressions involving variables. This is a fairly simple, quick lesson where we're mostly just kind of introducing some new vocabulary to you. So I'm going to put my green line here, my dark green pencil, and get ready to put in some notes. Let's see, we have 2 note cards here, and they'll probably just barely fit. Just put them one on top of the other here. And the first one is vocabulary, and the second one is methods for showing multiplication. Now, if you've been in my class, we've already talked a lot about these different methods for showing multiplication. But this is the actual lesson where it's introduced, and we'll go over that again. So first I'm going to glue in this vocab one here. And get it up as high up there in the corner as I can. Give it a chance to dry, and we'll get started with the other one. All right. Okay, and you can always just fast forward this part where I'm putting this in, if you haven't already. All right. Okay, just fits. All right. Okay, so let's yellow highlight our titles here. This one is vocabulary, and this one down here is going to be the methods for showing multiplication. And we'll talk about our vocabulary first. All right, so this is truly new vocabulary for most of you. We're going to be talking about what is a variable. Oops. Oh, come on. What is a variable? What is an algebraic expression? Okay, and then what the different parts are, what they look like. Okay, all right. So a variable is a letter that stands in for a number, and it could be any letter. It could be it could be any letter of the alphabet. In fact, I mean, it could be symbols. It doesn't even have to be a letter. We've kind of standardized on letters because it simply means this letter is representing an unknown value. We don't know what the number is that should be in this place yet, and so we're going to use this letter as a stand-in. Okay, it's important to know too that if you see an expression with multiple letters in it, like an A, a B, and a C, each one of those letters, because they are different letters, stand in for a different value. We'll make a note about that over here as well. But if you have an expression that has the letter X in it and it's used multiple times, that letter X stands for the same value every time you see it in the expression. All right? So an algebraic expression is simply a mathematical expression that contains numbers, operations, and variables. So before this lesson, we've been talking about expressions. Say like up here, this is an expression right here. We have a combination of numbers and operations. But an algebraic expression is going to have a combination of numbers and operations and variables. All right, so they're giving us an example here. This C times 55, which is really weird that they put that times symbol like that. Maybe because according to this letter, we haven't talked about the methods of showing multiplication. But in an algebraic expression, we would not use that. Why? Because X is a very common letter that we use for variables, and we wouldn't want to confuse this X and X for this multiplication symbol. But anyway, in this example, they are showing you an expression here. And the expression is C times 55. C is the variable. We don't know what C stands for. We don't know what its value is. And the variable with the operation, with a number altogether, creates an algebraic expression. Okay, we'll usually just shorten that to an expression, but officially, because of the variable, it means it's an algebraic expression. Okay, so let's go ahead and make a note about what I was talking about with the different kinds of letters in an expression, and we'll write that right over here. I'm using my brown pencil. All right, so if there are excuse me. If there are different letters in an expression, each letter represents a different value. All right. If there are different letters in an expression, in an algebraic expression, each letter represents a different value. So let me write an example. Here's an example here. This is a common formula for what we call slope. You'll learn that next year. We don't get into this in the 6th grade, but next year you most definitely will. So y equals mx plus b. All right, so we have 1, 2, 3, 4 different variables in this expression, and each one of these letters stands for a different variable. Maybe this y is 15. Maybe this m is 13, but it can't be 15 because the y is 15, and if we wanted to represent 15 begin again, this would have to be a y again in the expression. So each one of these letters represents a different number, a different value. We don't know what that is yet. And that's why we're representing them as variables. All right, so this is my example. And I'm going to write over here, not the same value, meaning this b here and this x here are not the same value, right? Because they are different letters. Different letters represent different values. Okay? All right, so with my light green pencil, I'm going to put a little line here. Oh. And we'll talk about something else. Show a couple of examples for what you're going to see on your worksheet today. So on your worksheet today, what they want you to talk about, what they want you to do is basically understand how expressions are written. And so it's taking words and writing them into algebraic expressions, or taking algebraic expressions and writing word phrases, all right? And that's really all it is. Let's talk just real briefly here about what's happening in this methods for showing multiplication. Like I said before, if you're in my class, we've already talked about most of them. All right, so you can show multiplication by using a dot, by using a parentheses, or simply the number adjacent to the variable. That means the number right next to the variable. All right, so I could have 4 dot y. I could have 4 with the variable y in parentheses, or I can simply, which is how we will do it most often, is simply have the 4 right next to the y. When any number is right next to a variable and there's no operation in between them, it automatically means multiply, right? And this is most often how we'll write them. There's nothing wrong with doing it either way, and in some expressions that's how we'll do it. But usually when we mean 4 multiplied by a variable, it'll be written in this way. All right, so let's see. What does the good to know say? One of the most commonly used variables. Oh, this explains why, kind of like what I was talking about up here. I don't know why they showed this X like that. That's kind of weird, because down here in the good to know, what do they say? One of the most commonly used variables is the letter X. Because the letter X looks so much like the multiplication sign at this little x, you will not use x to represent multiplications when working with variables. Instead, you'll use one of the methods above, the dot, the parentheses, or simply putting them adjacent like this. All right? Okay, so now let's write a couple of examples of how we write algebraic expressions from word phrases. So, write an expression for each phrase. Gotta write real small here. There we go. All right, write an expression for each phrase. All right. All right. So, first one is the sum of 6 and p, the variable p. All right, so there's a couple of ways we can do it, because, as we know, sum means addition, and in addition, order doesn't matter with addition. You know, we can apply the commutative property to addition, and so we could write this as 6 plus the variable p, or p plus 6, and either way would be correct. All right. All right. Next one. Okay, B. Let's try the product of 3 and m. All right, the product of 3 and m. Well, let's remember that product means multiply. And what did we learn over here about the different ways we can show multiply with variables? So the most common way that I would show this, if I saw this phrase, I would write 3m. Okay, this means 3 times m when they're just simply adjacent to each other. But I could also write it 3m, or I could also write it 3 times m with the dot, and those are all correct. All right, last one, let's do 7 less than x. All right, now let's remember that less than is telling us this is going to be a subtraction problem, but the thing we need to pay particular attention to is order most certainly does matter when we're talking about subtraction, as it does with division. All right, so there's only one way I can write this, unlike this one where I could write it both ways. There's only one way I can write this, because we're saying that 7 less than x. All right, so that means x minus 7. Subtract 7 from x. All right, if I wrote it with the 7 first, that would mean x less than 7, and that's not at all the same. So I know this, as we're learning this, is often the most tricky part, both with this and with division, is figuring out, okay, what are they saying? Which one goes first? Because as we know, it certainly matters. All right, so that's it, guys. That's our notes for this lesson. Let's go ahead and move on to the practice problems. Okay, so lesson 2.1 practice problems. I'm just giving you, there's 2 different problems that you'll be seeing, 2 different kinds of problems that you'll be seeing on your worksheet, and I'm giving you a sample of each one of them in your practice problems here. So this first section here, the first 6 ones, is write an expression for each phrase. That's what we did in our notes. So you'll just read each one of them and then write out the algebraic phrase that these words are representing. And there's some addition, some subtraction, some multiplication, some division. So there's some practice in all of the operations for you. All right. Now the second one is kind of flipping it over the other way. So now they're giving you the expressions, and they want you to write out a word phrase that would represent these expressions. Okay. All right, so I'll go back to the top, and you may pause to work these out. Okay, so let's see, how do these work? All right, well, first one, it says 5 more than x. So that is going to be, more than is going to be an addition operation. So I have 5 plus x, or x plus 5, either one. I think I like x plus 5 better because of the way it says more than x, but either way is going to be proper. Okay, so 4 subtracted from p. This is one. There's only one way, and order is going to matter. If I have a variable p and 4 is being subtracted from it, then it's it's p minus 4. All right. All right. 9 times m. Well, again, there's more than one way we can do this. My preferred way would be 9m, but it could also be 9m. It could also be 9 times m this way. All right, all of those are correct. All right, the quotient of c divided by 3. This is something that you'll see in algebraic expressions. Most of the time, they want division problems expressed with the fraction bar. So the more correct way on this one would be c divided by 3, like that. Now, if you wrote c divided by 3, That's not incorrect in this context, but it often doesn't work in algebraic expressions very well because of the other things you'll be doing with it. So this is the more common way you'll begin to see division when we're working with algebraic expressions. All right? Okay, so let's see. Number 5. A number n decreased by 13. All right, so a number n, that means that's our variable. We don't know what that number is, but it's going to be decreased, subtraction, by 13. All right? Okay, number 6, 5 times a number x, right? So 5 times a number x, again, that would be my preferred way to write it. You could write that with parentheses or with the dot, but that's how I would do it. All right? Okay. Now, let's write a phrase for each expression. So this means y minus 2. Now, I can simply write y minus 2. But there are other ways we could do that. We could say y decreased by 2, right? We've seen that. And I bet you could think of one more if you look back at our notes. We could say 2 less than y. Okay? There's more than one way to do it. This is probably the simplest one. You'll, with your eyes, just kind of makes you say that that's how you would read it, and that's fine. That's a perfectly fine answer. All right. So what did we say about division here? Okay, this you could the simplest way would just be to write r divided by 5. Oops, divided by 5. And that's fine, but you could also say the quotient of r divided by 5. Let's see. Is there another way? I'm drawing a blank right now. But this is fine. Keeping it simple like that is just fine. All right? All right, now we have 2 operations in this one because we have a multiplying with this 2 times w, no operation in between those, this coefficient and the, coefficient, well, that's a vocab word we'll learn later, but that's the number in front of a variable. But when there's no operation between them, as we've discussed, this automatically means multiply, and then we have an addition operation here too, or as well. All right, so we could write this as 2 times a number w plus 1. All right? And there's probably more than one way we could write that one for sure. Okay? But that's the most obvious, just kind of reading left to right. Okay? So that's what this lesson's about. Pretty simple on that one. Let me show you the worksheet. It's very much like what we just did on our practice problems. The top section of it is simply writing the expressions that these phrases are telling you about. This middle section here is write the word phrase for each of these expressions that you see. That's just like the second half of the practice problems we did. And on these last 2, they want you to find what are 2 different word phrases that you could write for this one, and write 2 different word phrases for this one. Okay, so we talked about different ways we can write, different ways we can use words to express these expressions, and they want you to come up with 2 for each of those. All right, so that's your worksheet, and that leaves us with exit ticket. Here's your exit ticket for lesson 2.1. As you know, I don't give the answers for exit tickets. This is for your extra practice, and your teacher may use it in some other way during your lesson as well. All right? Okay, so that's lesson 2.1 out of the Introduction to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.